Okay, so we are live. Welcome back to everyone who is watching right now and everyone who will be watching the rerun. I am Aditya Bansal. Welcome to my stream. I'm glad to have you here. I solve Python questions, lead code problems. Right now, I'm working on lead code problems to improve my programming skills, and I will continue doing that for quite some time, and then we'll move on to reading the Python documentations, and I think because that's the better way to learn. So we'll see how that goes. But yeah, welcome to the stream if you're watching live, and also thank you for watching if you're viewing this as a rerun. Let me just fix some stuff and then we'll get started. Okay, so yeah, Leetcode has this very useful study plan, and they have multiple things, list of questions that you can solve, top 100 liked and stuff. The one that I like the best is top interview 150 questions, not because I'm preparing for any interview or something, but just because these are good. Uh, this is a good list to go over the all the programming approaches. We have array and strings covered in the first section. This is a long string. And I've solved many of these before we're using Python. So I've solved much more, but back then I was using C++ to approach these problems, and I've shifted to Python since then. So now I'm solving these questions using Python and applying those data structures and algorithms to this. And hopefully we'll get through this list soon. This is just as a refresher. I am putting the hard questions on hold for now because they take too much time and I don't think they're really that necessary to understand the concept as a whole. And sometimes even the solutions can be a bit hard. So we will handle those, but we will handle those at last. Yesterday I solved the spiral matrix question, and today I'll be doing the rotate image question. So to get started, let's just say it for the clip. Uh, Hello! Today I'll be solving the rotate image lead code question, and we'll see how that goes. So let's get started. So our question is, you are given an n into n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, so we have to manipulate the same matrix list, which means you have to modify the input 2D matrix as it is. We are not supposed to allocate another 2D matrix to do the rotation. So that limits us, like we cannot just create a new matrix and put the numbers here. The location we are replacing, we have to take care that that is being properly uh, taken care of. So suppose if we replace 1 with 7, then we need to make sure that 1 is also preserved to be moved to this location. Now what this rotation means is all of these numbers are going up here and all of these are going down. So this is coming here, this is going here, this is going here. So if we can find some symmetry, this is our current line and then we are flipping it. So I don't think we have a symmetry like just change these and that would be easy. So we have to consider where is this going? And I think we have a n into n, so our matrix is square. That is good. So we have that flip this with this, and then we basically have to figure out the math on what the operations will look like. So if we start with just where should the first one end up, it should end up at the last. So if we can figure out some math, some formula on how to manipulate this, then that would make our lives much simpler, much easier. We are doing this whole diagonal is going like here, and then 7 is going up, 3 is coming down. So can we go by shifting these things around? Maybe that this inner part stays in the inner part. So maybe what we can do is shift this by 4, and then shift this by 4, this by 4, and then this by 4 in this direction, because everything is just moving in by 4 in this direction. And then 1, 2, 1, 2, 3, and 4. Okay, so just 1, 2, and 3. And in here, it is just moving 1. It's just moving 1 time. So we have whatever is the length of that row. What we can do is, let me just write this. 5 will go 4 steps. So basically, whatever is the row length minus 1, that much times we have to move forward. And that forward will obviously be a little bit more complicated because the direction is also changing. So let me just create a matrix with the coordinates. First is 0, 0, then 0, 1, 0, 2, 1, 1, sorry, 1, 0, 1, 1, 1, 2, then we go 2, 0, 2, 1, and then 2, 2. So it's like 0, 0, then 0, 1, 0, 2, I go 1, 2, 1, 2, and then 1 and 2. So this has to change into our new thing, which is 2, 0 comes up here, 2, 0, and 1, 0 comes here, right? 4. So yeah, 1, 0 comes here, and then our 0, 0 comes here. Similarly, for the next part, our 2, 1 comes here, 1, 1 stays here, and then 0, 1 comes here in place of 9. So 2, 2 comes here. 6 was at 1, 2. So 1, 2 come here. And then 0, 2 comes here. So we have to basically perform these operations. Our center one remains the same. So for 0, 0, we have to transform it to 2, 0. And then, so basically this whole row becomes 2. And then we go in like 0, 1, 2. And then this whole row becomes 0. And this whole row becomes 1. And similarly, if we do this for the bigger matrix, it can be like, let's just take some locations, 0, 0 will go to the end. And then the thing that is coming on the top is again the last row. So it will be 0, 0. 1, 2, 3. and at the end it would be like 30 will end up here, right? 20 will end up here, 10 will end up here, and 00 will end up here. So basically, we know that how the elements are going to move. Now, if we can get like a temporary variable, maybe that can help, because we already know like the swap we have to make. So are there any positions that are changing like exact values? So one is going into another place. I don't think that's happening anywhere. So we start from 00, it ends up here, and that value ends up somewhere else. So it will be 0010. So if we are at any position, can we guess based on the row number? So if you are at 2, initially, you will end up in the I minus this, and then, okay, so let me try. 2 will end up at the location of 20, or 20 will end up in the location of 00, 21 will end up in the location of 10. If we were just trying to brute force it and create a new matrix, how will we go about that? We will just start at this location and keep filling it? No, I think. So yeah, I guess first we have to figure out like if we were creating a new matrix, how we will fill that. And then we can use some variables and some clever techniques to optimize that so that we don't need a separate thing. So if I was creating a new thing, then I would go, I have to uh, rotate it 90 degrees. I think it should be something like a formula, like maybe there's a matrix that we can minus, subtract from the whole thing, and then, so if we have both of these things, the start and ending, we can see that it's going -2 and 0, then it's going minus +1 and -1, then it's going uh, it has to be like some simple plus minus, because suppose we can hard code anything, because suppose we have 1,000, yeah, it goes up to 1,000, no, it goes up to 20. So if we have a 20 by 20 matrix, how that will change? The last will come to the fourth, and For if we start iterating, just like if we have a single number, we don't have to do anything. Okay. And if we just start iterating, that 5, first we iterate to 5, then we have to place it in its correct position. And how do we calculate its correct position? We go, so even if we replace it with its correct position, we have to then change that because otherwise this will be lost. How does 0, 1 plus 2 steps get us there? We go for I5. Then how do we even calculate like where does it end up? Because all we know is that we have to move uh, plus 2 or plus 3, 1 to 3 steps. That's all the information we have, or that we need to rotate it 90 degrees, rotate it 90 degrees. What can that other thing be? I think we have to like, I cannot think of anything much about this. So let's see. Uh, yeah, this is just some Pythonic code, simple, but we are not going to do that. So for I in range n by 2, for j in range n minus n by 2. Why are they doing this so in Pythonic way? We don't want a Pythonic way. We need a common method to rotate things. Okay. They reversed it and then they swapped elements. Anti-clockwise rotate. First reverse, left to right, then swap the symmetry. Okay, but if we just directly swap the symmetry, it goes like, so we have a matrix n by n, vertical reversal, flip along the horizontal axis, transpose, swap rows and columns. Combining these steps, we need these two things, as he's saying. Vertical reversal, let's see what's that. In this step, we will flip the matrix upside down for every column. The topmost element swapped with the bottommost element. The second topmost swapped with the second bottommost, and so on. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, we get the opposite 7, 8, 9, 4, 5, 6, 1, 2, 3. Okay. This aligns the rows correctly for the next transformation. Transposing a matrix swaps the rows and columns. In simpler terms, ij becomes ji along the diagonal. So yeah, that is the main confusion, because if we just swap it along the diagonal, it's not going to work, because currently our diagonal is 159 and not 5, not in this direction. So if we had 1 here, okay, so basically what that allows us to do is We put 9 up here, 1 here, then we switch it, and then they become in the correct place. That's something. The matrix after vertical reversal basically becomes in the form that now we can just swap it and it just goes into the correct place. First, we'll iterate over the rows until the middle of the matrix. For each column, swap elements in the top and bottom rows. Iterate through the upper triangular part of the matrix, excluding the diagonal. Swap the elements symmetry across the diagonal. So we have our top, bottom, and then while top is less than bottom, we are just going to like basic 2-pointer iteration we are doing. For each column, we are going that uh, this is our column, top column. In Python, we can do this in one line, I think, right? I have no idea why they did it in two, but yeah, we can do it in one. So for each row, we will go column and then row plus one so that we exclude the diagonal, and we'll go to the edge, like go to all the other elements, and then we'll swap them again. So in like retrospect, this is a very easy solution if you already know how to do it. The major thing to figure out was that we had to flip. The vertical flip was a difficult thing because currently in this state, the operations don't make much sense. But if you just flip them, like this goes down here, then you can easily see that, okay, just a simple flip does the trick. And this one goes up here, then a simple flip does the trick. But currently going from this state to this state directly is a bit more difficult because you have to like traverse this way. You cannot do swaps, simple IJ swaps. So that makes it a bit more difficult. So now that we understand correctly, we need to perform two steps. First one is a vertical uh, swap, vertical flip. Top rows become bottom rows, and bottom rows become top rows. And then we just do a diagonal swap, like uh, swap elements ij to ji, excluding the diagonal because the diagonal will not is not supposed to be changed if we have 5 4, but then which diagonal are we not changing? Because if we flip it, it becomes 5, and then if we write the simple one, let's just write the simple before we write the excluding the diagonal part. Let's try to run this manually once. It will go 7 8 9, then 4 5 6, and then 1 2 3. So 7 5 and 3, after we did this switch like up to down, 7 5 and 3 are already in order. We only have to like handle this small triangle, so we have to avoid this diagonal because it's already in place. So excluding the diagonal. And how can we exclude that diagonal? We'll just row, and then we'll start with row plus 1. We'll go till the end, or we can even go end minus 1, but it's okay. We will go till the end. And first, let's do a vertical flip. So one common thing I would suggest is that even if you can't solve a Leetcode problem fully, even if you have to look at a solution once, then don't try to copy paste things or even like revisit the solution many times. Just read the solution once thoroughly, even make notes, and then come back and try to solve it manually yourself without any copy pasting. That will help you like practice on minor details that you might have missed if you copied the whole thing. So we do a vertical flip, and then we'll do a diagonal swap. So for vertical flip is we will use 2 pointers, top and bottom, like they did in the solution. Our top will be 0, our bottom will be length of matrix -1. And while our top is less than bottom, we'll iterate and keep swapping them. We will go for each column, in, so I would say for J in length of, we can say matrix 0, because all the rows will have equal columns. Or we can just even create a variable. I like to create a variable about the length because I don't want to rewrite this every time. If I find myself reusing a variable a lot, just create a separate variable for that. Because the rows and columns are the same, we can just reuse n for I in range n. We will go for each of those elements, and then we will go matrix. We are doing in place operations. So top of J is comma matrix bottom J. Hopefully this should work because this works with normal variables. Let's see if matrix gives us any issues, and we'll just flip it. So matrix bottom J becomes top and top becomes the bottom. Right, so this should flip our whole matrix from top to bottom. So this will give us 7, 8, 9, 4, 5, 6, 1, 2, 3. And now we have this diagonal set. And to check, let's just print the matrix. For that, I think we have to use a loop for row and matrix. Print row. Also add a label, print matrix after the vertical flip. And then we have to return nothing. So let's try running this one. So we're just checking that the vertical flip is correctly executed, not the results, but yeah. Time limit exceeded. So, okay, yeah, don't make the same mistake as I did. We have to update top to be +1. And then we also have to update bottom to be -1 because we have already seen those rows. So we update those and then we run it. Not to submit it, just run it. Otherwise, it will keep infinitely reiterating on that. So we have successfully changed 1, 2, 3 from the first row to the last, and 7, 8, 9 from the last to the first. So this operation is successful. You can also see it for the second one, case 2. Yeah, we have done, we have changed the rows vertically. And I guess we also did it for the other rows here. So now we only have to worry about the diagonal swap. So diagonal, some solutions I find that even after reading the solutions on Leetcode, some Leetcode questions I find that even after reading the solutions, they still stay like hard to solve because the logic of the question and how we should approach this solution is intrinsically so hard that it's difficult to break it down and even understand it. It usually happens in hard questions, but there are some medium questions that can be categorized as hard medium questions, and those can give you trouble. I usually try to steer away from them initially when I'm practicing. They are to be approached later on because there is no need to dwell on those and think you're bad just because you can't solve those questions. uh, Try to practice more and get a whole good grasp on like the basic concepts as much as you can rather than like feeling bad for not solving some of those questions. So that's like a good approach to take. It's a balance, and once you are familiar with solving each of the easier questions, then you can approach the harder ones as well. So for diagonal swap, we can go. Uh, we have to go one for each row. We will start with row plus one. So we'll go handle this and this, and then for this one we will go only for this element, and for this one we have nothing. So for I just use simple variables. No need to overcomplicate things. For I in range, we are going over all. So n, and then for j in range, we are iterating over uh I plus 1. So if you are at 0, we are at 0th row, we have to start at index 1. So we'll go with I plus 1. We have to make sure we are going to the end. So I to n. N will obviously be excluded in the range. And if we are out of range here, it should automatically not execute anything. And now we just do a simple vertical swap. And for that, we can use the similar one-line logic that we did before. Our matrix ij will become matrix ji. And now if we were doing something like C++, we would use a temporary variable and stuff, but here we can do in place swap. I am not sure what this is called. We will ask Grok what is this exactly called in Python, but we can just do ij becomes ji and ji becomes ij. And after this, we should ideally have our result, and we are updating the variables here only, so we don't need to manually update them. And we are ignoring the diagonals, and this should ideally give us the right answer. Let's run and check and see what we get. So yeah, this seems to be working for the test cases. Let's try submitting it once and see what results we get. Yeah, the solution that we saw, this one makes sense. Like, if you know, this is the type of question, if you know the two operations that you have to perform, writing the code is very easy because you have a clear logic that you just have to flip it and then swap. So, this is not that difficult to remember. And if you see it in the interview, it becomes very easy to code. And let's just analyze what is our time complexity and stuff. So we are iterating over most of the elements once. So we are going over O of n into n elements once. And then again in the diagonal swap, excluding the diagonal elements, we are going all over on over all of them. So it will be n into n by 2, which still stays n square. So whatever is our matrix, so in this case, it will go max to max 20 into 20 plus O of 20 into 20 by 2. Basically, because we have a upper limit of n, so it will go O of 400 plus O of 200 or 600, if you can say it like that. So in this simple cases, this makes sense. But yeah, we have to iterate over the matrix twice to just flip it once and then swap them once. This will be our 90-degree rotation. And I think for any rotation, 90, 180 or negative 90, some type of swapping is always involved. You're just you have to just consider which elements to swap and if it needs a flip in horizontal direction, vertical direction, or something like that first to allow this flip to properly work and put the final elements in the correct place. So let's try to read some other solutions if we can find them. Any different approaches. This is just explaining how they did it from top and then transpose. Diagonal swap is called transpose. And then analyzing SO of row into columns. Space complexity is 1 because we are not creating anything else. Key takeaways is the matrix is modified directly, minimizing the memory usage. This approach works for any square matrix, regardless of the size, combines the two straightforward operations to result in O of n squared times. So this is great. We can upvote this solution as well to thank them. Whenever you find a solution helpful on Leetcode, don't forget to upvote that solution. That usually helps the writer, whoever wrote this solution, to get more visibility. It might help them grow their YouTube channel and stuff. They are helping us. We can help them back. This is the simplest way to do it. And so you should do it. And then I think we also have the Leetcode editorial, which I don't have the premium subscription right now, but we might get that in future. So we will take a look at that sometime in the far future. This is doing the same thing. One line approach. Yep. So the same thing that we did. And then let's go to the list. Since we were able to do this one pretty fast, I think we can take a look at the next question in the list and try to solve it. Maybe we will not be able to solve it completely today, but we can at least look at it and get into the mindset of solving it. We are given an m into n integer matrix where of this name, and if an element is 0, set the entire row and column to 0. We must do it in place. So the one thing doing it in in-place solution is that if you update the 0 and make it like a 0, and then you come back to it and assume that this was 0 originally, that can mess up the whole thing. It will also make this row 0, and we have to avoid that. So I think one way we can do it is create a list of like which rows are 0 and which columns are 0. And first we will uh, iterate over the whole thing once, iterate over the whole matrix once, and then if we find a 0, then we can record the row number and column number in a list or something, in a list or set. And then then in the second iteration, we can go and we have to go either element by element. So if the row is in like one way to approach it, so like approach 1 will be to like again iterate over the whole matrix, and for each element, if their row number or column number is in the predefined list, in the list that we just made, then make that element 0, right? And then so this will be the first approach. Another approach will be to go in the list. So like iterate through the list, iterate through the row list first, row list, and for each of those rows, uh, change all the elements to 0. Right. And then again, iterate through the column list. And then for each of those columns, change all elements in that column to 0. So when we do this approach, we have to iterate over all of the elements again. So whatever is n into m, we have to iterate over. So we need this first thing just to maintain a record of what's happening. So we cannot just go and mark like we saw a 0 here. Now let's just mark everything 0 in this row because or can we do it? So we are iterating 0. We see our first 0. But okay, the problem comes in this case. When you see a 0 like this, we don't want to go back, forth, like we don't need to go up and back again and again whenever we see a 0. We want to do it in one go and have a clear approach, like we are iterating in a fixed manner and we are updating things. We don't want to go back again and again. You see 0 again, then you go back all the way again. This can lead to like a lot of changes and it can increase the complexity as well, I think. So then we create a record because suppose it's all zeros, then you're going back to every row again and again and again and again. It becomes, I guess it would become O of n cubed, which would be way worst. So then here we are taking O of n into m time. This is how many iterations we are doing. Then again, this is how much we are spending on iterating. And then if the checks will ideally, if we use a set, it will take O of 1 time only. And so this essentially stays the same. And if we take this approach, then we go O of n times. And then again, because maximum what can happen is all of the elements is 0. So we go once and then we have to go again for the columns and it will become this. So I say this is much worse than this. So let's just go with approach 1. Let's initialize our variables. We are maintaining a track of, let's say row list. So this should be a set. They will be unique. And then a column list. This will also be a set. And then we are iterating over I in range. Yeah, at the end of the day, it will be mostly be the same. I am not 100% sure about this. Yeah, because 2 into this is essentially the same. We don't consider this. But I am also not sure about this. I think the hash function is always O of 1. We say it is, but it can increase if I'm not wrong, if the hash itself is very long. I don't think we have to worry about that because here we have m and n very small. So let's just go with the approach of for I in range, we have, I like to make different variables for these just for the sake of it. Oh yeah, that will be like very helpful. Yeah. But then again, like, I don't want to complicate things. Let's just keep things to set now. We can obviously do that to keep it in like in an interview to O of 1. So thank you for that suggestion. I will look more into like how to do that efficiently. So we'll iterate through the n, and then for j in range m, let's just say if the element is equals to 0. Do we have strings or do we have numbers? We have integers, right? Yeah. If it is 0, then row list will also get an element, and column list will also get an element. And then again for I and range, basically this whole thing. So now we have to check if I is in a row list or j in column list. Then we just make this element ij is equals to 0. And then are we returning the thing? No, we are not returning anything. So did I correctly implement the whole approach that I initially first laid out? We have two sets. We have n and m. Then we are iterating. We are adding those. Then we are changing those elements. Ideally, we don't have to change if it's already 0, but who will check that again? So let's try running it once. I do prematurely run a lot of things because like it's okay. If I get an error, I get an error. If we're just doing it for fun. But yeah. So technically this is a correct solution. Let's try a Boolean array or a bit mask. So that would be like a list of row list that will obviously go under this. Let's also move this under this. I will just keep the name same for the sake of it. O of 0 into n, and then column list will become 0 into m. And then if it is the thing, then we do row list at position I is equals to 1, and then column list at position j is equals to 1. And then we say if, let's also keep this in comments. If row list at I or column list at j, then just update the matrix. Ij is equals to 0. And that should also technically work. Yep. Yeah. So thank you for this suggestion. Like this is a good, nice thing that I don't usually think about. My mind directly goes into sets that just use a set. But yeah, this is a good option for if anyone asks me like, how can we ensure this to be O of 1? Then this is great. So thank you very much for that suggestion. So today I like solved two questions. If we go like I did rotate images and then I did set matrix zeros. I was expecting them to take a lot longer, but I was able to solve both of them in 50 minutes, which is like still a lot of time, but I do a lot of random talking in between. So it's good. Oh, let's take a look at this. Oh, this is a hard question. So yeah, obviously it makes sense to be stuck on this one. Uh, you are given an array of nums of n integers and a 2D integer array of queries q where query is ln For each query, you must find the maximum XOR score for any subarray. I think I looked at this question before, maybe or something very similar, but I don't think I was able to get anywhere with it, honestly, because okay, yeah. At least you know a lot more. I think, yeah, I saw your channel as well. You do a lot of lead code questions more than me. So yeah, I have been on and off lead code. So if I go into my profile just for fun, it has been, yeah, a lot of times since I solved, but like I used to solve some question, but still a noob. So You're given an array of n integers and a 2D integer array, queries of size q, where queries I is this. For each query, we must find the maximum. The XOR of an array A is to be found by repeatedly applying the following operations on A so that only the elements remain. Simultaneously replace AI with AI. So all for all, this is swift. Remove the last element of A, return any answer Q, where array is to the query I. Okay, so these are like our indices. And for each of these ranges, we're finding the maximum in the first query. It has 6 subarrays. We are. Yeah, like time complexity is obviously like sucks. In almost like all solutions, I would say. And and XOR has like always confused me. No matter how many questions I've solved of XORs, they still end up being a little bit more difficult for me. Any binary operations, they just don't fit right. In the first query, we have 6 subarrays. We have to check all of them to like get an answer, something like that. So yeah, honestly, like even if you solve it completely, and even after I look at the solution, chances are I will not be able to get it because XOR solutions are tend to be pretty much very difficult. You're doing a lot of XOR solutions. You're doing ANDs in between for some reason, and then other binary operations sneak in. So yeah, uh, all the very best for this ones. And this also gives me another reason, like why I stick to medium ones right now, because they are just like fun to solve and get things going. And most of the time in interviews, I've seen like they only ask medium ones. In all of the interviews I've been, uh, oh, okay. So yeah, you even use binary shift to divide and multiply by two. I have not seen anyone. Oh, okay, great. Nope. I between 0 and 1, like I've not even seen anyone do that as well. So yeah, great. How do I actually switch between 0 and 1? Because uh you said like you can do or, but yeah, that division is like understandable. Yeah, but I just say like no, I have not seen anyone actually do that in practice. But that's great. Like you're using some other thing than the normal thing. Yep. And is there any another way to like switch between 0 and 1 doing some minus or plus operation? Because I know that 0 minus our variable is used to switch between -1. Oh, okay. 1 minus x. Yeah, that's what I was looking for. So 1 minus x. Is that I like if I remember it, that's how I usually switch between 0 and 1. But now I know another way to switch. I can just do x and then or 1. Oh, sorry. Oh, why am I pulling blank? Is this even or this is this and? I will ask Grok. I will not bother you. I will ask Grok. Right. Is this or operation in Python or and? Give me a fast answer. Oh, it's XOR. So I just made a fool of myself. Okay, great. Yeah, so now I know another way to like switch between 0 and 1. It's just XOR. Game of life. According to Wikipedia article, the I don't think I will be able to solve this game of life question today, but let's see how far we can go today. So, according to the Wikipedia article, the game of life, also known as life, is a cellular automaton devised by the British mathematician John Horton Conway in 1970s. The board is made up of M into N grid cells, where each cell has an initial state. Live, it's represented by 1, or dead by 0. Each cell interacts with 8 neighbors, horizontal and vertical, using the following 4 rules taken from the Wikipedia article. Any live cell with a fewer than 2 live neighbor dies and causes as if caused by underpopulation. Okay. So if it's 1 and it does not have 2 live neighbors, then it dies. Any live cell with 2 or 3 live neighbors live to the next generation. Any live cell with more than 3 live neighbors dies. Why? Overpopulation. Wow. Any dead cell with exactly 3 live neighbors and become a live cell. Okay, any dead cell with 3 becomes a live cell by reproduction. And then the next state of the board is determined by applying the above rules simultaneously to every cell in the current state of M into N grid simultaneously. And then given the state of the board, update the board to reflect its net state. You don't need to return anything. We have to make the changes in place. So for each one of those, I guess like the brute force solution will be to like have all the indexes we need. How many does it interact with? 8 neighbors. So it interacts with 1, 2, 3, 4, 5, 6, 7, 8. So all of these we have to consider. We can create a map like a map of all the um, like uh, dx and dy's we need to consider. Y's we need to consider. And then for each one of these, we will just go and check for all of these locations and count the number of ones. Uh, and essentially we will have like a complexity of n into m into 8 because we are checking with like 8 positions for each of these cells. I think for like today, I will just quickly try to code this one and see if I can come up with something better, maybe tomorrow. And so it will go, we are not supposed to say 0, 0. So we will go -1, comma -1, because we have to check like if we are here, we have to go 1 up diagonally. And then we have to go 1 up. So just -1, comma y 0. So this will put us here. And then we have to go 1 forward in the up direction. We also have to go 0, -1. We also have to go 0, +1. We also have to go 1. Basically all of this. 1 with all of this. And then for each I in range, I think that we should create in length of board. M is length of board 0. Okay, let's call it max call, max row. Actually, for the rows and columns. For I in range rows, for j in range columns, we'll go on each of the elements. And it only depends on the neighbor, right? And so first we have to count it anyway. So let's just count first. For each of those, we'll maintain a count. And for coordinates, so basically for dx, comma dy in map, we will go if it's greater than equal to 0, what I plus dx and smaller than rows minus, basically smaller than rows. And it is in range for y as well. So for this is what we learned yesterday, like how to just simply check the whole range. We can just go 0 greater than. So we are checking if this location exists, then count will just become board I plus dx and j plus dy. So now we have the count, and now we need to apply these rules. Any cell, live cell, so we'll have to check if it's live or not, the current one. So if our board ij is live, else not live. If count is less than 2, then update board. Okay, so we also have to can't just update it because that will also change how we are counting things. So we have to essentially create another board. Next state will be a row for it's wait. Do we create a populated matrix again? Next state for in range rows. We go next state dot append 0 into columns. And we can also do it like in between one line. Next state is equals to 0 into columns for in range rows. So we have our next state currently this. And then if it count is less than this, then we go next state ij is not live. Elif if it is 2 or 3. So basically more than 3. The count is more than 3. Then it dies. So it becomes this. Else we don't make a change. So we could have replicated this, but okay. So currently I am creating a new thing, but new board, but we were supposed to just update the board. Let's see how that goes. And later we can figure out a way to do it in place. So for non-live cells, if it is exactly 3, then we update it to 1. Else it stays at 0. And then at the end, we have to update our matrix. So for I in range rows, for j in range columns, we update the matrix ij to be equal to next state ij. And since we are not returning anything, that should ideally be it. Okay, it's bold. Yeah, it is working correctly, but we'll see. I think it might be taking a bit too long, maybe. No? Okay. So how do we do it in place, basically? Because that will essentially alter the state and we have to perform like operations further down. So if I update this position, like, okay, this is alive now, and then we go to this location, this will incorrectly assume that this is alive. So we have to avoid that mistake. So we need a separate location for this anyway. So maybe we can keep a list of changes. So instead of like the whole thing, uh, change list can be a thing. Like, or maybe just a change list. Change list will be a list of coordinates. List of coordinates that we have to change at the end. So if count is smaller than 2 or count is greater than 3, we add the location to the change list basically. So change list dot append, and then we go append I comma j basically. And then if count is equal to 3, then we again change this to this. Right, so we can also do like a little bit more longer, but if board I j is equal to 1, and this, basically then only change this lf board I j is 0 and count as 3, then change this. You can obviously make it more complicated, even just append these, but that doesn't make much sense right now. So yeah, now we are not iterating over everything. We'll just iterate over for I and j in change list, and then we will just make those changes. Board ij will become, as we just learned, to flip 0 to 1, it will become 1 minus this. So this way we are not creating a whole new matrix. We are just keeping track of what coordinates we need to flip. So we're just doing those flips at the end. So that worked as well. I think in solutions, we can go C++ solution maybe. They're doing some complex math for some reason, but okay. Yeah, they're just using like the values 2 and more, like, okay, this is flipped, but we don't need to do that right now. Because again, that will take like we have to iterate over it again. Essentially, we can just basically what they have done is updated it to maybe say 2 or -1, so that changes. Then we need more logic here. But it's a valid way. If you don't need to, if you don't want to store a change list, just update it to like 2, 3 more, some other value, so that, and you will need another logic a bit here. So that will simplify things. So essentially today we were able to solve rotate matrix, set matrix zeros, and game of life 3 questions, which is like great. I was expecting to solve one. I was able to solve 3. This is great progress. And thank you for joining. Catch you next